Hi, welcome to AIMS University Malaysia. In this session, today I am going to teach you what are enantiomers, diasteriomers and meso compounds. First, let us see what are diasteriomers. Diasteriomers are the stereoisomers that are not mirror images of one another and are non-superimposable on one another. Stereoisomers with two or more stereocenters are called as diastereomers. It is sometimes very difficult to determine whether or not two molecules are diastereomers. Let's look at the examples given here. These molecules are non-mirror images of each other. Additionally, these molecules are non-superimposable because if one of these molecules is flipped 180 degrees, so that the alcohols and methyl groups are aligned, the stereochemistry is different at one carbon, that means the carbon with alcohol groups, and the same at another carbon, that is the carbon with methyl groups. So therefore, these molecules are diastereomers. Now let us have a glance on enantiomers. Enantiomers are the chiral molecules that are mirror images of one another. Furthermore, the molecules are non-superimposable on one another. This means that the molecules cannot be placed on top of another molecule and give the same molecule. Chiral molecules with one or more stereocenters can be enantiomers. It is sometimes very difficult to find out or determine whether or not two molecules are enantiomers. Let's see the examples given here. These are the molecules which are mirror images of one another. Additionally, these molecules are non-superimposable because if one of these molecules, the one on the right hand, is flipped 180 degrees so that the chlorines are aligned and the stereochemistry is different. One chlorine is wedged and the other is dashed. Therefore, these molecules are enantiomers. Here there are some examples given which shows both diastereomers and enantiomers. D-threose and L-threose are enantiomers to each other. The same way D-erythrose and L-erythrose are enantiomers to each other. But L-threose, D-threose are diastereomeric to D-erythrose and L-erythrose. Now let us see what are meso compounds. A meso compound is a molecule with multiple stereocenters that is superimposable on its mirror image. These particular traits led to the specific qualities that the meso compounds do not share with most other stereoisomers. One such quality is the internal mirror plane. All meso compounds have the same thing called as an internal mirror plane. This internal mirror plane is simply a line of symmetry that bisects the molecule. Each half is the mirror image of the other half. A meso compound requires at least two stereocenters. A compound with only one stereocenter cannot be considered as a meso compound as it would not be a chiral and would not have another stereocenter to oppose its optical behavior. So, any molecule can have stereoisomers, but not all have internal mirror planes. The mirror plane should bisect the molecule. The meso compound must be symmetric about the internal mirror plane. Each opposing stereocenter must have differing absolute configurations and the attachments on each stereocenter must be the same. If the opposing stereocenters have the same absolute configurations or the attachments on either side are different, then one half will not be the mirror image of the other half. Let's see an example. We can take tartaric acid as a basic example for meso compounds. Tartaric acid is an organic compound that can be found in grapes, bananas, and also in wine. The structure of tartaric acid itself is really interesting. Naturally, it is in the form of RR stereocenters. Artificially, it can be in the meso form RS, which is a chiral. RR tartaric acid is enantiomer to its mirror image, which is SS tartaric acid, and diastereomers to meso tartaric acid. RR and SS tartaric acid have similar physical properties and reactivity. However, meso tartaric acid have different physical properties and reactivity. Here is the structural representation of tartaric acid. The left hand and right hand structures are enantiomers to each other, and the structure below is diastereomer. The structure below is also called as a meso compound because it has a plane of symmetry. The melting point of RR and SS tartaric acid is about 170 degrees Celsius, and the melting point of meso tartaric acid is about 145 degrees Celsius. Here we end up with diastereomers, enantiomers and meso compounds. Thank you for your patient listening.